So, hi. Fast and furious, that means that because I'm now second and running out of time, I'll try and be super quick. But if you find that I'm going too quickly, or you want to stop me just to ask a question, please just do that, okay? And Seb will tell us if we're running out of time, okay? Good. So, hello. We're a vendor. I'll try not to be too vendory today, but if you want to talk to me about vendor stuff afterwards, I'm around all day. I'm the CEO of Weaveworks, so I won't be as technical as the previous speaker. In fact, I bet most of us would be less technical than the previous speaker. It was a really good talk. Thank you very much, Ricardo. And thank you also to the sponsors. I'm also still, for the next few days, the TOC chair at the CNCF. I've been doing that for 3 years. I'm really looking forward to finding someone else to do this. We now have a new TOC, Technical Oversight Committee, at the CNCF, which is responsible for defining which projects are in the CNCF and what they do and how they're governed. And what I really liked about Ricardo's talk was basically, if you want to do everything he said at home, with the exception of one thing, you can do it using CNCF technology. All you need is a super collider in your living room. Apart from that, it's easy. So I'll be talking about these things today. CNCF, a bit about cloud native, and a bit about GitOps. So a bit about my company, just quickly. We're a VC-backed company, and we help people make Kubernetes clusters using GitOps, which is essentially a form of configuration management. In GitOps, every single thing that you do is a configuration, and you manage everything that you do through making changes in Git. That's the idea anyway. And then you have tools, which, like orchestrators, which automatically or semi-automatically take what's in Git and apply it to the cluster so that you get correct state. And the hard thing about this is scaling it. You know, I don't know if you could make it work at the scale that Ricardo just showed us at CERN, because you've got many different clusters, many different applications, many different services, many teams, many versions, many branches, an N to M by N by O by P by Q by R tensor of possibility. But it is possible to make it scale to enterprise, and that's our customer base. Still quite a small team, but growing very quickly, and we're hiring anywhere in the world. And Seb mentioned this before, I've been responsible for a number of projects, some more disastrous than others. And the team also includes a lot of people from Ubuntu. I see a few people from that world here today. And yeah. So, basic idea of today is, whereas cloud led us to DevOps, cloud native takes us to GitOps. And GitOps is a kind of automation for cloud native that helps you go faster, but in a controlled way. And if you want to have simple takeaway, it's operations by pull request, in which you use tools that were originally created for developers to drive operational changes in a manner that is safe and audited and shareable, which is really cool, actually. So, cloud native. We asked earlier, who's heard of the Cloud Native Foundation? And last night, I was talking with somebody in the audience. We had a really interesting chat about this. And I said, what do you think of when you think of the Cloud Native Foundation? Oh, it's that landscape thing. OK, who here has seen this thing? OK, I've made it really tiny. What happens if we make it bigger? It's still really tiny. I'm really, really sorry about this, OK? I've been trying to get rid of it for the last 2 years. It's embarrassing. Just ignore this. This is basically a huge distraction. The Cloud Native Foundation is actually something much more important than a diagram. There used to be a better version of this document, which we're going to revert to eventually. But here's the point. CNCF is the home of Kubernetes. It's what makes it possible for Google and Amazon and Microsoft and CERN and Weaveworks and TriggerMesh to all work together on one piece of code. A neutral home. I hope you all know what Kubernetes is. It's a Linux for the cloud, essentially, a new way of organizing processes across machines. It's very popular, although I just want to be clear, the Cloud Native Foundation is not just the home of Kubernetes. It's also the home of some other projects, and you don't need to use Kubernetes to use those projects. Again, in Ricardo's talk, he gave some examples. CSI, Prometheus were two that sprang to mind. Core DNS is another. I don't know if you're using that. And these things are all usable independently. Prometheus is a monitoring tool that was written at SoundCloud for managing AMIs. originally. And microservices. Core DNS is a rewrite of a pre-cloud native DNS implementation by Mick Gieben, who runs 888 at Google, or used to. And by the same token, you don't have to use Kubernetes for orchestration. Although Ricardo was advising against it, you can write your own orchestrator. The problem is you have to maintain the damn thing. So if you work at Netflix and you're Andrew Spiker, they've written their own orchestrator and they're willing to maintain it because they're Netflix and they've got unique, huge demands. Similar in scale to CERN, but not the same shape. You can use Mesos, you can use Swarm, and I'm not here to tell you that you must use Kubernetes, but it is right now kind of the VHS, emerging orchestrator format. In the future, we may be using other things. It will probably adapt to the use cases. By pooling together lots of projects, we are able to get high volume of contribution and activity, meetups. This particular meetup in the future might be in collaboration with the CNCF because it's trying to expand how it works with companies like Exascale to do small-scale events for a few hundred people like this one. The main conferences are now at the scale of thousands of people, so they're kind of too big to just have for a casual business meetup. And that makes it possible for people to get together and learn about these new technologies, which are frankly quite confusing, and will be for still a little while. And that's a snapshot of the projects. I don't need to list them all, but there's about 4 or 5 that have graduated, which means they're now sort of fully qualified. Kubernetes, Envoy, Prometheus, and I think Core DNS, if I remember correctly. FluentD is coming through to graduation. Things like gRPC and Containerd you've probably used. There's a couple in there that probably won't make it past the incubation or sandbox stage. Like RKT, for example, looked very interesting for a while, but I think most of the folks who worked on it have moved on to other container projects. But it still played a very important role because it showed that there could be multiple reference implementations of the open container standard. And now we actually do have that. So I think you had 3 on your slides, CRIO, Containerd, and Docker you mentioned throughout your presentation. And there are others as well, like Kata containers. And the ability to have something that can be a packaged runtime that could work in different places, like on ARM chips, on IoT, for example, but still be a container and therefore be manageable by Kubernetes, means that we can imagine this orchestration tooling expanding to cover use cases like Internet of Things in the future that it's not currently necessarily working with so much. Which also highlights another really important aspect of how to do these foundations, which is you want to decouple the projects. You don't want to say, Project A has to wait until Project B has finished a feature before Project A can do a feature, or they have to coordinate excessively in order to agree on a format for something. So generally, all of these projects work independently, and we have what we call minimal viable governance, which is a new thing relative to OpenStack and Apache. Because in OpenStack, they wanted to have a single stack, hence the name, OpenStack, which is great because you can say to enterprises and telcos, one set of technologies for one private cloud, it's just going to be amazing. And then what happens? It turns out it's very difficult to coordinate multiple projects into one project, especially in the open source environment. Linux has done it, but Linux is very unusual, and it's not the same thing as OpenStack. Even Kubernetes is growing to that kind of size, where it's got multiple different parts that need to cooperate. I've lost the screen, guys. Teal? OK. Right. There you go. Anyway. So why does this matter? We're trying to get to a place, and we're not there yet, where everybody in tech, more or less everybody in tech, can focus on building applications that have value to consumers, to society, to governments, to education, and to business. And we're not at that point yet. We're still tinkering with preemption. It's exciting to talk about, but we really shouldn't be worrying about this stuff too much. So a bit more about how this comes together, and what the principles are. So you might have heard people use the analogy before that software is like Lego. Who has heard this analogy before? Yeah. Well, it is in some ways. Let me talk about what makes Lego cool. So it's a system of components. And with those components, you can build very surprising things. Here is something from Legoland in the UK, I believe. Legoland is also Brexiting, by the way. This is an actual working car, apparently. I mean, I think it, when it got off to the right-hand side of the screen, something terrible may have happened, but that is actually moving in that photograph. This is from one of my dreams. This is art. You can do art with Lego. And so, when the CNCF began a few years ago, you know, we had some components, but not much idea about how to put them together. And we've invited users to get involved. There are now 75 user companies in the CNCF, and I think it'll grow to hundreds. And we're now seeing people build real things. That's what Ricardo just showed you, a real thing, an amazingly real, important thing. It's really cool. And so what's it going to do next? So the goal is to get to a cloud platform so that everybody can use it, and they can have a cloud platform which works anywhere, and then to focus on building applications and you know, data solutions, IoT, what have you. And so, sorry, actually one more thing about that. Another key point about it, sorry, is that it's very much like Linux. It's an open thing, which means anybody can use it. So, you know, you don't have to ask permission to start a business or start a project using these technologies, which creates a new kind of framework for innovation, even around the world. I mean, one of the things that's interesting right now is we just had a vote for the TOC, and I'm very disappointed that I was re-elected. It's a very good thing. But apart from that, I was very disappointed that all 6 of the people who got voted in were white men of my generation, which is pretty poor. And that immediately started a discussion about diversity, which is a never-ending topic, of course, in tech now, very important topic. And the Americans are saying, well, you know, we've got to have more women, more people of color, underrepresented people. I'm like, wait a minute, you know, you do realize that if you go to South America or Europe or China, people say, well, how about some committees without just Americans in them, actually?
Yes.
And, you know, I've got a friend who lives here, actually, but he's from Uruguay originally, who organized a conference in South America, and he was trying to get sponsors for it. And he couldn't get sponsors because, why are you doing a conference in South America? It's clearly irrelevant, was the attitude he got from software companies. So there's a lot of work to do. So making something open is a fundamental stepping stone to make it something that everybody in the world can get involved with. And that includes people from China, from Japan, from Africa, and other places like that. The second thing that's really cool is that for the first time since the 1990s, everybody is on board with the same direction in the CNCF, meaning, what do I mean by that? For example, with OpenStack, that was supposed to be everybody against Amazon. That worked really well. With Linux, it was everybody against Microsoft, which worked quite well, actually. With this, it's like the web. It's actually something that everybody's agreed on. It's Amazon, Microsoft, IBM, Google, who couldn't agree on, you know, shoe color and hat size, can agree on getting these technologies moving together, which I think is really cool and gives you a high degree of faith in betting on them yourself. So that is the power of a foundation. So what can you do with it? You can go faster. What do I mean by faster? Okay. This is a photograph I took in a Hadoop project a few years ago that I was involved with. And you can see a number of sadly typical IT phenomena in this photograph, including the tendency towards command and control and an overemphasis on long-term strategy. With Kubernetes and the era of components that we want to work together but are not mandating at the level of committees have to, where we create an environment where innovation is simple, what happens is people by themselves, without having to be told, feel they already have permission to create something new that solves a problem quickly and plugs into something that already exists. Example, Kubeflow. So TensorFlow was created at Google. It's an open sourcing of some machine learning algorithms. People use Kubernetes. People were struggling to get TensorFlow working. And some bright spark said, why don't we make it easy to start Kubeflow on Kubernetes? It's like, you know, making Spark easy to run because you get rid of yarn. That's a genius idea, right? So once you've installed Kubernetes, or you use GKE or EKS or one of the cloud services, bingo, now you can easily run TensorFlow, which means that, which I believe Ricardo said that he was experimenting with his colleagues. This means that if you work for a company, for example, a bank, and you read about machine learning and you're thinking, we could do something with machine learning, and you want to convince the boss to put money into it as opposed to some other project like building a data center, then great, now you can have a POC up and running in hours, days, maybe a few weeks, and show somebody examples that prove the point, which is a lot better than, first we must choose a vendor. Then we must do 3 POCs, one with each vendor, and bring in some consultants. But wait, now we have to choose a consultant as well. Should it be Accenture or Pricewaterhouse? And then you're doomed already. You've lost before you've started. So you can have self-propelled innovation from the bottom up, anywhere. So this is all about componentization. That's what we're trying to do. It's a componentized platform. And here's an example of that in action. Here's a photograph from a video of a skyscraper in China. I took this picture from the internet. This is the Guardian newspaper online last year. And what can we see here? This is a half-built skyscraper, and the story is all about how it has 57 stories, which is a lot, and it was built in 19 days by this company. That is possible, and this is not a one-off. That is possible because they're using components that they can slot together, and when one component is not available, they can find another component to replace it because there's enough interoperability due to the level of componentization, which is not the same thing necessarily as standardization. It just means there's an acceptance across the entire supply chain that assembly is critical. So in the case of containers, as I mentioned, we had RKT and Docker. Now we have CRIO and Containerd and Docker and Kata containers and blah, blah, blah. And that's an example of interoperability. So this is taking the same idea and applying it to tech. And just as an opposite story, I'm sorry if you've seen this story before. Can you see this, by the way? I can tell you what it says. This is a quote at the bottom from Douglas Adams in 1992, who wrote a book called Mostly Harmless after he did Hitchhiker's Guide. And he's talking about his hero of his book. And it says, he's a really hopeless person. Left to his own devices, he couldn't build a toaster. He could just about make a sandwich, and that was it. That sort of, I feel the same way, actually. And this guy, Thomas Thwaites, read that and thought, this is interesting. I can make a sandwich, but could I build a toaster? And so this person, Thomas, decided to build a toaster from scratch without componentization, meaning sourcing every single component by hand and assembling every single component them himself, and then assembling the toaster out of these kind of natural components. It took him about a year to do. What you can see on the cover of the book, The Toaster Project, which describes this, is the end result, which happened after he switched it on, and it immediately melted. But this is, what happens if you don't have componentization. Many IT systems look a little bit like this, by the way. So, who wants to build a toaster in a year? Not many people, maybe some mad people. Who wants to go fast? People using platforms and components that fit together want to go fast. And the idea of lower barriers to entry is also very, very appealing. The Kubeflow example there, Seb's new company, Trigger Mesh, is a great example of this. Putting things together closer to the user so we can add more value is really important on top of the infrastructure that's layering in already. This is what we expect to see if we get this right, an explosion of innovation in higher order systems. A load of cool new stuff that sits on top of the new stuff that hides the old stuff that you can use immediately. And velocity is one of the things that people talk about in the context of continuous delivery. I don't want to spend much time going into the details of that. So you end up with this whole combination of what are we doing? We're enabling developers to write code that powers applications, not infrastructure, and creates customer or other services, and live on top of this cloud platform, which is driven by continuous delivery at high velocity. And when you've got all that, then you can do, in tech, something a bit like building that skyscraper in 57 days. You can make things quickly, you can experiment. If you don't like them, you can change them. So the way that you're thinking about how you spend money in tech changes because you can experiment more and manage risk much more effectively, which is great. And if you're in this room and you work in a bank, I ask you to contemplate this very seriously, because of course you have regulations, you have compliance, you have other things that slow you down. But there are also benefits to moving quickly, because you get stability through actually fixing things when they go wrong. And if you move slowly and things go wrong, you can't fix them quickly. And that's a real problem. So what does this platform look like? Due to the PDF that I made earlier, it looks rather strange in color, orange and blue. Sorry about that. But what we're trying to get to is this feeling of, please just run my code. Don't make me think too hard about kind of how the application is scaffolded. And so the way that's going to work is, in practice, is an orchestrator, and we think Kubernetes is the leading candidate, some other CNCF projects, your local database, and the infrastructure it runs on, and then application frameworks on top, whether it's Spring, or PHP, or Kubeflow, or something else. And there's lots and lots of things appearing already that let you run your code, and increasingly these things are running on top of the platform, which is great. And so, to summarize, this is a kind of roadmap for the CNCF to get to the cloud platform. On the left, you can see sort of stuff we've already added, like observability, monitoring and logging, tracing, some routing and mesh solutions. In the middle, the job for the next couple of years is the CNCF is federating into individual special interest groups, which function a bit like the Kubernetes SIGs, focused on key areas like pipelines, for example, or observability, or security. And as soon as we announced this, we started getting inundated with people saying, we want to do one for this, or we want to do one for that. But it will mean that we'll start to have, the CNCF will start to scale out away from just Kubernetes and Prometheus and Envoy to probably a large number of projects. And that will enable us to create the environment where we can think about the application frameworks afterwards. And that's where we want to get to in the future. So anybody can write some code, and it will just run. And this will be very useful when, in the future, there are more developers, because the developer population is growing about 15% a year. Right now, depending on how you count what is a developer, the number of developers is between 10 million and 25 million. There's about 25 million active developers with accounts on GitHub, for example. And if at 15% growth rate, that means we'll have 100 million within 10 years, which is a lot more people, 75 million of whom haven't started using GitHub yet. And they will be using these tools, not what we were using 15 years ago. So with tools and changes in tooling come practice changes, and I'll finish up the talk by talking a bit about those and GitOps. And these things can get very tribal. You know, people were very much into DevOps when it was a thing, and it still is a thing. As I said, we get from cloud native to GitOps in the same way as cloud led us to DevOps. So what is that? So this is a picture of Kelsey, one of my colleagues on the TOC. He works at Google, and he summarized the core concept of GitOps as the world, the source of truth. What's real is envisioned as a repo, or actually a set of repos, image repos, config repos, other kinds of repos, and not a running installation. So your source of truth is what's intended, not what's actually running. You have two sources of truth. You have desired state and running state. So what problem does this solve? The problem that we're trying to solve here is, what is the operating model for Kubernetes? How do I actually think about updating apps, monitoring them, and managing them in a practical way so I can make changes at the promised high velocity of the platform? And we at WeaveWorks started talking about some best practices that we had stumbled upon through running Kubernetes from about 4 years ago. And through doing that, realized that we were recreating patterns that people had evolved in DevOps, but doing so in a manner that made sense for the era of declarative infrastructure, tooling like Terraform and Kubernetes, where you have complete state descriptions or complete system descriptions in your config files. We needed to document this and show people how it worked, and other people said, we're doing this too. So a little kind of group emerges of people talking about this practice. And it's building on many, many, many years of DevOps. DevOps really begins in about mid-2000s. People start, well, not true. Basically, Martin Fowler and Jez Humble and some people at ThoughtWorks started talking about this back in 2002, 2003. And you were using Subversion, and they talked about continuous delivery, but there was no tooling for it. It was something they kind of imagined and thought about how automation could work. And then they were actually building on work done by Mark Burgess with CF Engine in the 90s, with the core concept of intended state driving changes in a real system. But things began to take off really in the late 2000s when more and more people start building websites that need to be changed frequently. That's what's driving it, is the idea of frequent change and how you bring that under control. And eventually you end up with Kubernetes, which is a tool for making changes to a system automatically based on a description. And I'm going to give you an example of the benefits of this. Here's a company in San Francisco that we worked with. They wanted SOC compliance. They were using Jenkins to do CI and Google Cloud. And they do machine learning. And they started using GitOps to make changes. And they found that their productivity went up by a very significant amount. I'll show you the numbers here. So originally, they were making 1 or 2 releases a week. Sometimes Jenkins would have a partial release or a partial failure, and then they had to reboot the cluster from scratch and start everything again. They also had to stop working on other things while the whole team did a single release. And they started adopting these new practices, and they found that they could have multiple teams all doing releases independently, and the releases would either succeed correctly or they would fail in a clean manner so they could try again. And that meant that they could go up to about 30 releases per team per week, and they had much quicker response in terms of fixing bugs and solving customer requests. So that kind of benefit is very appealing. We've looked around the industry, and there are all sorts of people talking about or using GitOps. I think Ara from Bitnami is here. Might say something about sealed secrets or something later on. The Financial Times was talking in Copenhagen there in the picture. I like the comment, if you can read it, that the metric for success is the number of sarcastic comments on Slack. And other people too. I mean, Ocado, we were talking about this last night over dinner, that Ocado is not just a grocery company, it's actually a tech company now. And one of the main things they do is they have robotic warehouses where when you order groceries online, somebody will fill a basket in the warehouse with your order, and then that will be put into bags, and it'll be brought to your house in a truck. And when the basket gets filled, a robot goes around the warehouse and it picks up things and puts them in the basket, which is kind of incredible. And so all of this is driven by Kubernetes, and they're making frequent changes a day, because you can imagine with a complex real-world system like that, a lot of things go wrong and they have to be fixed. Turned out they were using the same GitOps-style approach, which we were really delighted to hear about. And it's a pattern. It's not something where you must use a particular technology from one company, which is another good thing. OK. So what are some other key points about GitOps? I mentioned that it's automation for cloud native. How does that work? It works by the notion that you can automate and control what you can describe and observe. So this means that we're taking the core ideas of DevOps, version control for all our config, and automating everything that we've described, and then describing as much as we can. And what we do is we describe monitoring, dashboards, policy, code, config, the entire stack, machines, containers, clusters, security, everything. We really take it to an extreme. And we keep everything either, well, I use this as an abbreviated thing. Everything is either in Git or in a set of image repos. And what happens is once you've got a running system, you have a control loop which is constantly inspecting what's in the desired state in the repos and comparing it with what's in the running state. And if there's drift between them, if there's a difference, you'll get alerted, and you'll be able to either automatically or manually take action to fix it. And this is what's called an OODA loop. Who's heard of an OODA loop? Nobody? OK, so observe, orient, decide, act. It's a concept invented in the 60s by an American fighter pilot, and it became central to modern control theory. And it's the basis of high-velocity operations in places like the nuclear industry as well. And it's trying to identify what is the decision loop that you must make to operate a system. And this is why we can talk about an operating model for managing Kubernetes clusters. Because what you must do is you must observe. Orient means essentially filtering information that you can observe into some intelligence, decide what to do about it, and take action. And if you're building a GitOps system, what you're doing is you're constructing a system that observes the running Kubernetes and the whole stack, compares it with what's in Git, filters out what's important, e.g. pulling out a diff alert as shown here, and then you take action to fix it, which may be automatic or it may be manual. And that gives you a very simple operating model for your cloud-native stack. Which also means that any developer who can use GitHub can get involved very early on. You don't need to teach them a whole load of complicated tooling. They can start by making changes to the system safely by updating the repos, which contain things like this. This is, you've probably seen this before. This is a YAML for Kubernetes describing a system. And we're applying, these things are appearing everywhere. So for example, I'm not going to show you today, but the approach of declaring the properties of a correct stack is also being used in Istio and in various serverless implementations, and we use it for progressive delivery at Weaveworks with something called Flagger. And so you've got your descriptions. What about observability? You can think about this as observability-driven development. Okay, once you've got a description, you have the basis for identifying whether or not a deployment is correct. So you can actually, provided you can take your description and compare it with what you observe, you have a mechanism, therefore, for seeing if the described state is the same as the observed state, which means that you can validate a deployment. This is very important in a complex cloud-like system, or you can be told if it's gone wrong. And so we just take that to a great extreme at Weaveworks. So what does it get you? One source of truth, one source of desired state truth, separation of concerns. You can't directly write to the cluster because you're only making changes to the repos, which means you can also have policy gateways to protect people from messing up production. You can integrate with existing review tools. You can actually get a form of rollback and roll forward and a version history for your running stack. You can use it for compliance. We've had people go through SOC 2 with using this and Sarbox. And it's a collaboration point. And we apply it to all of those things. So you can really take this process a really long way. It's very different from what we call CI ops, where instead of using Kubernetes and the orchestrator to drive updates based on telling Kubernetes that a change has occurred, you instead allow your CI tool to drive updates. This is crossing the security boundary from CI into production, which many people will tell you is a major security threat vector, and also has the ability, basically because once you own Jenkins, you can potentially own production from there. So setting up barriers to prevent that is quite fiddly. So this model is easier to make safe than that. And we think of it as a firewall between CI and CD. What is that firewall? The firewall is the Git repos, the image repos, and the other repos. And the way it works is the CI can only ever update the repos. Okay, it can't update production directly. And CD only takes things out of the repos. It doesn't actually have write control on the repos. So this is what you get as a pipeline. That's a typical CI/CD pipeline with read-write everywhere. And this is what you get with the GitOps pipeline. So you can see there's a build loop, and not CI doesn't go away. CI probably becomes more important, actually. But you've got build orchestration on the left-hand side, and you've got Kubernetes pulling changes into itself from the repos on the right. Something like this. So nice, secure, compliant model. Everything is tracked in Git. Anyone who makes changes, you can find out when they happened, what happened and why. And as I said, I'm not showing you here, but you can introduce policy gateways. You can have things like a third party does checks that a container is signed and other such properties that you might need in a high regulatory environment. Security, very important. I've said quite a lot about this. People often ask, how do you do secrets here? The Bitnami team developed a technology called sealed secrets, which we use, and that allows you to basically have secrets that are inside envelopes, which themselves can be opened by an operator running inside the cluster, which means that you can stop somebody reading them in Git. For example, they can be encrypted. You can also integrate this with tools like Vault, if you're using Vault as a central enterprise secrets authority, which gives you a very nice GitOps system backed by Vault. So to summarize, this is what the operating model looks like. You've got these two interlocking cycles of change. And if you have this in your mind, this is how you're going to be changing all of your cloud-native systems in the future. On the left, there's a build test cycle, which is powered by CI, tools like Jenkins, CloudBees, GitLab. GitHub Actions is a very exciting development in this space. GitHub Actions is a serverless solution for composing workflows to drive arbitrary build processes on the left-hand side and therefore create very complex GitOps workflows. Some of those workflows you also see with tools like Argo. Some of the build in machine learning use cases, for example, involves many stages. At Netflix, they do many stages of build as well because they have a lot of smoke tests. And then I've put Git, but there are a number of repos in the middle. That's the immutability firewall. And on the right-hand side, you've got all of your runtime tools that are driven by changes in Git. So they are observing the repos and then automatically making changes based on those observations, using Kubernetes to orchestrate and drive consistency in the cluster, not manual intervention. So that's the GitOps lifecycle on the right-hand side. Great. So I hope that's been an interesting survey coming from the motivations for cloud native and the foundation through some of the goals of the CNCF in the near term, and then finishing up with a few examples of what we do at Weaveworks with GitOps practices. Do you have any questions about any of this? Because I'm happy to talk about it for a few minutes if you like. OK, thanks very much, everybody.